Well, once again, we're working with our unified geometry, and remember in previous weeks we had some postulates and initial postulates of an existence and incidence, connection, and some propositions that related to that. Then after that we talked about distance and order. Got this idea of a distance metric and between. And this is when we really started introducing the unified geometry of the four infinite geometries we've been working with. Then last week we talked about angles and convexity a little bit, and we got through these definitions and propositions and another postulate there. And now today we're going to talk about a first of 2 weeks on triangles. So let's do not a lot here on triangles at this point, but let's get through what we have here on this page for postulates, definitions, and propositions so far. So we'll start with the definition. Given any three non-collinear points A, B, and C, we define triangle ABC as a union of the line segments AB, BC, and CA. Note that the notation with the little triangle ABC indicates it's a triangle, but it doesn't have to look like that triangle. That triangle shape there does not have to be what it actually looks like. So it doesn't have to be isosceles or equilateral or any other kind of triangle. Of course, it doesn't even have to be Euclidean triangle either. The interior of a triangle is the intersection of the interiors of the interior angles of the triangle. And then I should probably have this definition before that. Okay, the angles ABC, BCA, and CAB are called the interior angles. So just to illustrate this very quickly over here in Euclidean geometry, that's a triangle, ABC. But the interior angles are actually, of course, angles are rays. So there's an interior angle there. We might use the angle marker tool to mark it, but the actual angle, of course, is the set of two rays, even though we may not actually draw those out. That's the angle. Okay, so let me make that thin. And so that's the angle that we're talking about. But of course, this figure right here is the triangle. Okay, okay, another definition here. Need to put the points A, B, and C are the vertices of triangle ABC. So these should be familiar definitions to you. The interior of the triangle I can actually construct in Sketchpad. When I select the 3 points, I can construct triangle interior, and these points here are in the interior of the triangle. It's the intersection of the interiors of the interior angles of the triangle, and the exterior of the triangle then are the points that are out here. In general, we'll talk later on about a closed plane figure, and this one is a closed plane figure, and it will have a well-defined interior and exterior. But for now, we're just going to define triangles this way. It's a little more complicated to define a closed plane figure. For any exterior, okay, then you have an exterior angle. So an exterior angle, here's an exterior angle. So that angle there, this one here, is an example of an exterior angle. So the red is an exterior angle. So it would be, you know, out here. Okay. So we have exterior angles and interior angles. So an exterior angle, by definition, it forms a linear pair with one of the interior angles. So that exterior angle there, for example, forms a linear pair with the interior angle at B. Sometimes we'll be lazy and just say the angles of this triangle, and by that we'll mean the interior angles. The longest side of a triangle is called the hypotenuse. That's mainly used with right triangles, but we're going to use it with any triangle. Now we have some triangle classification definitions, and we'll look at some examples of this in a next video. But a triangle is scalene if and only if it has no two sides that are congruent. It's an isosceles triangle only if it has at least two congruent sides. It's an equilateral triangle if and only if it has all three sides congruent. A triangle is an acute triangle if and only if all of its angles are acute angles. It's a right triangle if and only if it contains a right angle, at least one. It's a triangle is an obtuse triangle if and only if it contains an obtuse angle, again, at least one. And four, let's clean this up a little bit. A triangle is an equiangular triangle if and only if all three of its interior angles are congruent to each other. Okay, and of course by these angles I mean interior angles. Let's make that explicit. Okay, in a right triangle, the sides that include the right angle are called are included in the right angle are called the legs. So if it has a right angle as one of the sides, then it's called a leg. Okay, so in a Euclidean right triangle, the hypotenuse is going to be the longest side, and the other two are going to be called legs. Now, so with those definitions, we can get a few propositions that are not very hard to prove. These may be assigned to some folks to present in class a little bit later on, but maybe next week. I'm going to think about that a little bit. I'm going to get back to you on that. Proposition 35 says each triangle is contained in exactly one plane. Proposition 36 says if triangle ABC equals triangle DEF, then the set of vertices ABC has to equal the set of vertices DEF. So DE and F are just renaming of the points A, B, and C. The interior of any triangle is a convex set. That's proposition 37. Proposition 38, if a line in a plane of a triangle intersects one side of the triangle, then the line intersects at least one other side of the triangle. If a line in a plane intersects one side of a triangle does not contain a vertex of the triangle, then the line cannot intersect all three sides of the triangle. And that's going to go back to that, very closely related to that theorem of Posh. Okay, now we're going to get to a very important definition right here. Given a one-to-one correspondence between two triangles, or a triangle in itself, the correspondence is a triangle congruence if and only if vertices correspond to vertices, sides correspond to congruent sides, the interior angles correspond to congruent interior angles. Okay, so if it has those things, then it's a triangle congruence. The two triangles are then called congruent triangles if and only if there exists a congruence between the two triangles. So we say triangle ABC is congruent to DEF and use that notation to indicate a particular congruence, not just that the two triangles are congruent, but they have a particular congruence, which is a particular correspondence. So in that congruence, A has to correspond to D, B corresponds to E, and C corresponds to F. So first one. So then line segment AB corresponds to line segment D, E, BC to EF, and so forth. And they need to do this in such a way that corresponding parts of congruent triangles are congruent. Sometimes we'll abbreviate that CPCTC. And so this gives you a list of several things that are congruent. Side AB, line segment AB, is congruent to DE. BC is congruent to EF. Line segment CA is congruent to line segment FD. So all three corresponding sides are congruent, and corresponding angles are congruent as well. The interior angle at A is congruent to the one at D. The one at B is congruent to the one at E, and the one at C corresponds to the one at F, and they need to be congruent as well. So you get all 6 pairs of measures of sides and angles to match up in a congruent fashion. So that's really all that we have thus far on the formal propositions and so forth. We'll be using these definitions in our exploration this week. I'll go back over in another video a little bit more detail about classifying triangles and talking about congruent triangles. I'll give 2 short videos on those, and those will be basically illustrated with Euclidean geometry. Then your tasks for this week basically are all going to be centered around what criteria, well, 2 things. What do the angles, interior angles, add up to, their measures, and what 3 pieces of information about, there's 6 congruences here. If I've given just 3 of them, are there any combinations of 3 that are enough to get the other 3 for free, basically, to make the triangles congruent? So those are going to be the basic investigations for the week.